Hi guys, welcome to TechNet Labs. Today we're going to be going over basic subnetting. I've had a few requests from a few friends on questions how to subnet, so I've decided to make a video on it today. So yeah, let's begin. So the first question we have to ask ourselves is, what is subnetting? So subnetting is the process of taking host bits to the network bits portion to create multiple networks in an IP address. So if I give you this example here, we have the IP address 192.168.1.0. And so the subnet mask tells us the split between the network portion of the IP address and the host portion of the IP address. This can be shown below in binary format, where each bit which is on tells us the number of network bits as part of the network. So this can also be shown using prefixing, shown as /24. So the /24 tells us the number of bits which are on, and the number of bits which are on tell us the number of network bits part of our network. So the first 3 octets are on, and so the dividing line is where there are no bits longer on. So it's between 3rd octet and the 4th octet. And so this is the split between the network portion and the host portion. And so what subnetting basically is borrowing host bits and transferring it over to the network portion to allow us to create subnetworks of this IP address that we have here. So yeah, the next question is, why do we subnet? So there's actually a high demand for IPv4 addresses. And so that has led to a shortage in IPv4 addresses. And so if I give you an example here, we have company X. And so company X have 3 departments, A, B, and C. And so typically what would be done when there wasn't a shortage and a high demand of IPv4 addresses, the company would just buy 3 different IP addresses for each department. So the first department would get 192.168.1.0. That's bought separately, and then buying another IP address, 192.168.2.0, and lastly 192.168.3.0. So the company would have to buy 3 different IP addresses. This sort of method wouldn't be very feasible since they would have to buy 3 different IP addresses, and that can be very expensive due to the high demand and the shortage in IPv4 addresses. So now what companies can do now, instead of buying 3 different IP addresses, they buy 1 IP address, let's say 192.168.1.0. So we can say that the first department can be assigned the first part of the network. So 192.168.1.1 to 20. And then the second department can be assigned the next part, saying 192.168.1.21 to 40. And the next department, 192.168.1.41 to 60. So each department get 20 IP addresses, and that's a cheaper option since they don't have to buy different IP addresses. And it's much cheaper for a company to do it this way. And so yeah, this is why we subnet. And so now, before we move on to our example on the next page, there's these 2 key definitions that we need to understand when we're doing our subnetting, and it's the network address and broadcast address. The first thing you need to know about these 2 addresses is that they cannot be assigned to users. So the network address is the IP address which tells you the beginning of each subnet. And so let me write that down for you. So it tells us exactly where the beginning of each subnetwork is. And the broadcast address, which is also used to send messages to all hosts of the network. It's typically the last IP address of the network. So let me just write that down. So now moving on to our example. Okay, so here's our first example. A company has purchased the IP address 172.16.10/24 and need to have the subnets for its 4 departments, each having 20 hosts. Okay, so the first thing I'm going to do here is just quickly rewrite the IP address 172.16.10/24. So what we're going to need to do is actually find out what the subnet mask actually is here. So as we said, the /24 tells us the number of network bits which are on. So that means we have to have 24 bits for our network. So starting from the left of our first octet, we would have that on, which means it'll be 255. 255 for the next one, which means 16. And the next one plus 8, that is 24. So 255.0. So that's how our subnet mask is going to look like. And now we have the split between our network portion and our host portion. So this is the point in which the bits are no longer on, and the split will be here. That will occur here as well. So that's our split that we have. So the next thing now we're going to have to do is look at the number of hosts. So each department needs to have 20 hosts. So we're going to focus on the host portion of our IP address. If we write that out in actual binary format, we're going to have 128, 64, 32, 16, 8, 4, 2, and 1. So there's a formula that we use to find out the number of host bits that we need to borrow in order to match our requirements of 20 hosts. And that is 2 to the power of number of host bits used. Host bits. And what that will tell us is the actual total number of hosts. So let me give you an example here. If we use the first bit as part of our host portion, we're going to have 2 to the power of 1, which is equal to 2 hosts. And next, if we borrow 2 bits for a host, it's going to be 2 to the power of 2, giving us 4 hosts. And the next one, 3, if we have 2 to the power of 3, that's going to give us 8 hosts. And if we borrow 4, that would be 2 to the power of 4, giving us 16 hosts. And then if we were to borrow 5, it would be 2 to the power of 5, giving us 32 hosts. And even 2 to the power of 6, that would give us 64 hosts, and so on and so on. So looking back at our calculations here, we can see that over here, when we borrow 4 bits, we get 16 hosts, and that is too small for our requirements since we need 20. So we'd have to go for our next best option, even though 20 lies between these two. So we'd have to go for 2 to the power of 5. So that's when we borrow 5 bits. So that would be 1, 2, 3, 4, 5. And so the dividing line between the network portion and host portion would occur here. So this would be the network portion, and this would be the host portion. And as we said earlier, the network portion would have their bits on, and the host portion would have their bits off. So the subnet mask would have actually changed because now we have extra bits that are on that will be joining the network portion. So the first 3 octets won't change. So it'll still be 255.255.255. However, there's 3 added bits, and we need to find out the value of these 3 bits that will be part of the last octet, and that is 128 right here, 128, 64, and 32. I'm going to add them up. Let me just redo that. We have 128, 64, 32. Add them up, 8 plus 4, that's 12. 12 plus 2, 14. Carry the 1, so that's 3, 9. 9 plus 3, that's 12. So that's 2. Carry the 1, so that's 224. So the last octet will have the value of 224 as its subnet mask. And that also can be shown using prefixing. So originally we had /24 when all 3 octets to the left are on. So if we're going to include these 3 extra bits, you just add it on to the number of bits which are on, and that will be 24 plus 3. So that's, again, so that's 24 plus 3, and that's 27. So that is the new subnet mask and the prefix. So now moving on to calculating each subnet, there's something special that we really need to take into consideration, and that's something called the special number. And that number tells us the increments between each network. So the first digit to the left of our binary number, we need to find out the value of it using our binary numbers, and that is actually 32. This number tells us the increments for each of our subnetworks, and so it will be 32. So our first network starts from 172.16.10.0, and so the next network will start from 32 for our last octet. It's 172.16.10.32. And then following that, the next increment will be 172.16.10.64, and then adding the last 32 to our fourth subnet is 16.10.96. So these are 1, 2, 3, and 4. These are our 4 networks. And so now what we need to do is find out our broadcast address, and just to reconfirm that we have 32 addresses in each of our subnets. So guys, I just decided to draw it in this way so that we can see our 4 subnets more clearly. So if we look at our first subnet, we have 172.16.10.0. This is our network address, which tells us the beginning of our subnet. If we just write down our first IP address of our subnet, that will be 172.16.10.1. Okay, and the next address that we're going to need to find out is our broadcast address. And our broadcast address, we said, was the address that is used to communicate with all of our hosts in our subnetwork. And the way we do that is by looking at our next subnet, which is 32. This is the second network for our subnet. So what we're going to want to do is -1 from this IP address to give us our broadcast. I'm just going to write broad, and that will be 172.16.10.32 -1. So this will be our broadcast address to communicate with all of our IP addresses in this subnet specifically. And so the last IP address usable for any of our hosts will be 172.16.10, and it will be 1 minus the broadcast. So the broadcast is 31, so the last address will be 30. So everything between here will be used for our hosts. So that's the first subnet. The next subnet, if I just quickly speed through this, the first IP address for our hosts will be 172.16.10.33. Our broadcast address will be 1 minus the network address of our third subnet, and that will be, oops, and that will be 172.16.10.63. Our last IP address will be 1 minus our broadcast address, which is 172.16.10.63. Oops, no, not 63. 62. And everything between here will be used for our hosts, part of this subnet. So the next one as well, first IP address will be 172.16.10.65. Our broadcast address will be 1 minus the IP address of our next subnet. That will be broad 172.16.10.95. Last IP address of this subnet will be 172.16.10.94. Everything between here will be our host IP addresses. And lastly, for our fourth subnet, the first IP address will be 172.16.10.97. So for our fourth subnet, to calculate our broadcast address, what we're going to need to do is find out what our next subnet will be. So by doing that, we just quickly, if you look over to the left, it's going to be 96 plus 32, which was our increments for our networks. And that'll be 6 plus 2, 8, 9 plus 3, 12, 128. So 128 will be the 5th subnet. So 128 minus 1 is 127. So our broadcast address will be 172.16.10.127. And so the last IP address will be 172.16.10.126. So everything between 97 to 126 are IP addresses for the host. And so if I just separate them for you here, you have the first network here, the second one separated here, the third network separated here, and the fourth one separated here. So we've met the requirements of 4 departments having 20 hosts. So thank you for listening. Make sure you like and subscribe, and let me know if you have any other suggestions for videos down below. Thank you.